This is Bob Capetta from the University of Illinois at Chicago, and this lesson is L'Hopital's rule, part 2. Here's a quick note that'll help us do a couple of the problems. Let's recall that the derivative of e to the x is e to the x. And the next thing to consider is what is the derivative of e to some power? And of course, the derivative of e to some power is e to that power times the derivative of that power. The derivative of e to the something is e to the something times the derivative of the something, using the chain rule. So for example, I have the derivative of e to the 5x. That would be e to the 5x times the derivative of 5x. E to the 5x times 5, or 5 e to the 5x. So again, that'll be helpful for us as we're doing our analysis. So we start with the question, the limit as x approaches infinity of 7e to the 2x over e to the 2x minus 9. X is getting very, very large. If x is large, 2 times a large number is very large. E to a large number is very, very large, and 7 times that is also ridiculously large. So the numerator is going to infinity, is trending to infinity. Same thing. If x is getting large, 2x is getting large, e to a large number, e to the 1,000, e to the 1,000,000 getting very, very large. I subtract 9 from a very, very large number, it is still a very large number. So the top is tending to infinity, the bottom is tending to infinity. And that's one of our cases where it's fair to use L'Hopital's rule. An infinity over infinity case tells us we can do that. Now to use L'Hopital, that says take the derivative of the numerator and the derivative of the denominator and then take the limit. So we'll show it as follows. The limit as x goes to infinity of the derivative with respect to x of 7e to the 2x divided by the derivative with respect to x of e to the 2x minus 9. So we can recognize that the 7 can move in front of that derivative operator. And on the bottom we have the derivative of e to the 2x minus the derivative of e to the 9, because the derivative of the sum is the sum of the derivatives. And now we're ready to use our rule that we did in our note. The derivative of e to the 2x will be e to the 2x times the derivative of 2x, e to the 2x times 2. Again, derivative of e to the 2x will be e to the 2x times 2. The derivative with respect to x of 9, the derivative of a constant, is just 0. Now simplifying this, the numerator we have 7 times 2, 14 times e to the 2x divided by 2 times e to the 2x. Notice the e to the 2x's cancel. E to the 2x divided by e to the 2x is just 1. 14 divided by 2 is just 7. So we have the limit as x goes to infinity of 7. Well, all of the x's are gone, and the answer is just 7. So the next problem is very similar to the first one. I encourage you to pause the video, try it on your own, and see if you can get the correct answer. So that is the limit as x goes to infinity of 5e to the 2x over e to the 2x minus 4. Pause the video and see what you get, and then check the results by running the video. So our first case is to determine whether the numerator and denominator are going to a fixed number or going to infinity. If x is getting very large, 2x is getting very large, e to a large number is a large number, 5 times a large number is a large number. Numerator going to infinity. Similarly, e to a very large number is a very large number, minus 4 is still a very large number. So both numerator and denominator are going to infinity. That's an infinity over infinity case. In that case, it is fair to use L'Hopital's rule. We're going to do that by taking the derivative of the numerator, derivative of the denominator, and then taking the limit as x goes to infinity. Simplifying this, the 5 comes in front of the derivative operator. The derivative of e to the x minus 4 is the derivative of e to the 2x, minus the derivative of e to the 4. Derivative of the sum is the sum of the derivatives. So here we're going to get 5 times the derivative of e to the 2x, and from our little rule, that's 5 times e to the 2x times the derivative of 2x, which is just 2. On the bottom, the derivative of e to the 2x is e to the 2x times the derivative of 2x times 2, and the derivative of 4, the derivative of any constant, is just 0. So simplifying the algebra here, we'll take the limit as x goes to infinity of 10 e to the 2x over 2 e to the 2x. The e to the 2x's cancel. 10 divided by 2 is 5. We have the limit as x goes to infinity of 5, which of course is just 5. Hopefully you got that right when you tried it. Our next example is the limit as x goes to infinity of 8 times the natural log of x divided by 7x cubed. We need to see what is happening to the numerator, what is happening to the denominator. If x is a very large number, a million, a billion, a trillion, the natural log of a very large number will get increasingly large, but very, very slowly. Whereas if x is a million cubed is a ridiculously large number, times 7 is a ridiculously large number. But the reality is, both numerator and denominator go to infinity. So we have an infinity over infinity case. Both numerator and denominator get increasingly large, therefore it's fair to use L'Hopital's rule. And then we take the limit of the derivative of the top divided by the derivative of the bottom. We can pull the 8 out in front, we can pull the 7 out in front of the derivative signs. The derivative of the natural log x is 1 over x. The derivative of x cubed is 3x squared. So upstairs we have 8 over x, downstairs we have 21x squared, and we have to divide those guys. So the limit as x goes to infinity of 8 over x divided by 21x squared. Dividing by 21x squared is the same as multiplying by 1 over 21x squared. So the 8 21s, 8 21sts can come out in front of the limit sign, and then I'm left with 1 over x cubed. Now as x gets large, 1,000 cubed, 1,000 times 1,000 times 1,000 is a billion, 1 over a billion getting very, very close to 0. So I have 8 21st times 0, and of course the answer to that is 0. So the next example I have is paired with this one. So I encourage you to study this carefully and then try the next problem. And then when you're finished with it, begin the video and see if you've done it correctly. So first step is to determine where the numerator and denominator are going. If x is going to infinity, log of x also going to infinity. If x is going to infinity, x cubed going to infinity. So 3 times something going to infinity upstairs, 11 times something going to infinity downstairs. So we have an infinity over infinity situation, and it is fair to use L'Hopital. So take the derivative of the top, the derivative of the bottom, and take the limit. Pull the 3 out in front, pull the 11 out in front. The derivative of the natural log of x is 1 over x. The derivative of x cubed is 3x squared. So here I have 3 over x and 33x squared, and those need to be divided. So limit as x goes to infinity of 3 over x divided by 33x squared. That's the same as multiplying by 1 over 33x squared. And the 3 over 33 could come out in front, and I have 1 over x cubed left. 3 over 33 is, of course, 1/11th. But as x gets large, a large number to the third power is a very large number. 1 over larger and larger numbers is going to get closer and closer to 0. So we will have 3 over 33, which is, of course, 1 over 11. This limit is 0, and our answer to this question is also 0. And we have one more pair of problems to look at. This time the limit as x goes to 0 of 2x plus 5, 3x plus 5 over 2x plus 7. What happens to the top? 3 times 0 plus 5, that goes to 5. What happens on the bottom? 2 times 0 plus 7, that goes to 7. So I have a 5 over 7 situation when I plug in 0. So my limit is 5/7. Now, the question is, would it have been fair to use L'Hopital here? Could I have taken the derivative of the top and the derivative of the bottom? The derivative of the top would have been 3, the derivative of the bottom would have been 2, and that is not the answer to the question. And no, it is not fair to use L'Hopital's rule on this problem, because when you plug in 0, you get 5/7. L'Hopital is fair if we have an infinity over infinity situation or a 0 over 0 situation. So let me ask you to quickly try the next exercise, very similar, and see what you get. As soon as you're done, keep rolling the video and see if you've done it correctly. So same situation here. Plug in 0, 6 times 0 plus 1, 11 times 0 plus 9. And what do we get? we get 0 plus 1 over 0 plus 9. 1/9 is the result. So not fair to use L'Hopital here, because again, the derivative of the top is 6, the derivative of the bottom is 11. That is not the answer here. It is not fair to use L'Hopital on this problem because it is not 0 over 0 or infinity over infinity. And that will conclude this lesson.